Hello and welcome back to Engineers Olympiad, where learning meets success. We're on to second chapter of surveying, that's theory of errors in surveying. We have completed the 5 video lectures of the same chapter, and this is the video lecture number 6. In case you want to watch those videos, they're already up on the channel. You can watch those videos before watching this video. So let's get started. Today we're doing the numericals of this chapter, and the first question is there is a standard error of plus minus 10 seconds for a measured angle of 71 degrees, 30 minutes and 20 seconds. Determine the range for which there are 50% chances that the true value would lie in that range, and also determine the range for the standard error and 99.7% error. All right, so let's solve it. Now the question says there is a standard error of plus minus 10 seconds for a measured angle of this. We have to determine the range for which there are 50% chances that the true value would lie in that range. All right. So please recall the discussions as held in the previous video lectures, wherein I told you that the most probable error is defined as that error for which there are equal chances that the true value will be less than the probable error or will be more than the probable error. Or in other words, I can say that the probability of the true error being less than that of the probable error is 50%, and the probability of the true error being greater than that of the probable error is also 50%. So the range for which there are 50% chances that the true value would lie in that range is given by calculating most probable error. And you know that true error is measured value of that quantity, any quantity for that matter, so minus its true value. All right, the difference between a measured value and the true value is known as a true error. All right, but both true error and true value are hypothetical quantities. Since true value is a hypothetical quantity, we cannot find true value of any quantity that is equal to arithmetic mean of infinite number of observations. All right, so it's a hypothetical quantity. We don't know the exact true value of any quantity, so which indicates we also don't know the true error. All right, because true error is the difference between measured value and the true value. All right, and the true value is that value of any quantity which is free from every type of an error. All right, so the range that there are 50% chances that the true value would lie in that range is given by the most probable error. Most probable error, and you know that it is equal to plus minus 0.6745 times standard deviation, or sigma, or I may write it down, it's plus minus 0.6745 times. We know that standard deviation is given by square root of summation of v square divided by n minus 1, where summation of v square is the sum of the square of the residuals or the residual errors or the variations. All right, so let us try to solve this. So it will be given by plus minus 0.6745 times sigma, right? But in question it's itself given that there is a standard error of plus minus 10 seconds. We know that our standard error is same as our standard deviation. So our standard error or standard deviation is plus minus 10 seconds. That means our most probable error is how much? Plus minus 6.745 seconds, or approximately, let's suppose, 7 seconds. All right, so our most probable error is plus minus 7 seconds. All right, so there are 50% chances that the true value, I'll write it down over here. So there are 50% chances that the true value will lie in which range? That the true value lies between, what is the observed value? Observed value is 71 degrees, 30 minutes and 20 seconds plus minus most probable error, that is 7 seconds. So the range is given by, it's between 71 degrees, 30 minutes and 13 seconds to 71 degrees, 30 minutes and 27 seconds. This is the range in which there are 50% chances that the true value would lie in this range. All right, so we have completed the first part of the question. It also says also determine the range for the standard error and 99.7% error. Let me rub it first. All right, let's do the second part. Determine the range for the standard error. All right. If you recall the discussions as held in the previous video lectures, wherein I told you that the standard error establishes the limits within which measurements are expected to fall 68.3% of the time, that is 7 times out of set of 10. All right. The probability of the error to occur between plus sigma and minus sigma is how much? 68.3%. All right. So there are 68.3% chances that the true value of that measured angle, this is its observed value. True value is a hypothetical quantity, cannot be found. But there are 68.3% chances that the true value lies between how much? What is the observed value? 71 degrees, 30 minutes and 20 seconds. What is our standard deviation? Sigma plus minus 10 seconds. So the range is 71 degrees, 30 minutes, 10 seconds to 71 degrees, 30 minutes and 30 seconds. This is the range for the standard error or the standard deviation. All right. And we know that the standard error or standard deviation establishes the limits within which measurements are expected to fall 68.3% of the times. All right. So this is the range for my standard error. I have completed the second part as well. Now the last part. We have to determine the range for the 99.7% error. Let me rub it first. All right. Now the third and the last part of the question says determine the range for 99.7% error. All right. We know that 99.7% error is expressed as E99.7. All right. And is equal to how much? Already discussed in the previous video lectures. It is equal to plus minus 3 times standard deviation. All right. E99.7 or 99.7%, I may write it down as 99.7% error, or E99.7 is given by plus minus 3 times sigma. So it is equal to plus minus 3 times, how much is my sigma or the standard deviation or the standard error? 10 seconds. So it is equal to how much? Plus minus 30 seconds. So what is the range for my 99.7% error? What is the observed value of this particular angle? It is 71 degrees, 30 minutes and 20 seconds. That is plus minus 30 seconds. All right. So this will lie in this range, 71 degrees, 30 minutes and 50 seconds to 71 degrees, 29 minutes and how many seconds? 50 seconds. All right. So this is the range in which my 99.7% error will lie, which is also known as, which is also expressed as E99.7 and is given by, is equal to thrice standard deviation. So we have completed all the 3 parts of the question. All right. Let's do the next question. All right. So question number 2. Question number 2 is, if the standard deviation is plus minus 0.03 meters for the mean value of the length of line of 615.41 meters, find the relative precision. Find the relative precision. All right. The question is, if the standard deviation is plus minus 0.03 meters for the mean value of the length of line of 615.41 meters, we have to find the relative precision. Relative precision, or the degree of precision, is used to express the precision of the various measurements, and it's usually expressed as a ratio between standard deviation and the mean value of the quantity. All right, so I may write it down. My relative precision, also known as degree of precision. So my relative precision or degree of precision is a ratio between standard deviation and the mean value of the measurement. All right, so my standard deviation is plus minus 0.03 meters, and mean value of the length of the line is how much? 615.41 meters. By calculations, it is equal to 1 by 20513.7, since we always express our numerator as unity. So this is the ratio, but if I'll like to round off my denominator, it is approximately equal to 1 by 20. All right, so this is the relative precision. All right, relative precision, or the degree of precision, is used to express the precision of the various measurements, and it's usually expressed as a ratio between standard deviation and the mean value of measurement. All right, moving on, let's do the next question. We're trying to solve as many numericals as possible for this chapter, Theory of Errors in Surveying. All right, we have completed the theory part. Those video lectures are up on the channel Engineers Olympiad. You can watch them before watching this video. All right, so question number 3. Question number 3 is, an angle is measured with a standard deviation of plus minus 2 seconds. Calculate the most probable error. Also determine 95% error and the maximum error. All right, so the question is, an angle is measured with a standard deviation of plus minus 2 seconds. Calculate the most probable error, also determine 95% error and the maximum error. All right, we know that our most probable error is given by how much? Plus minus 0.6745 times standard deviation. All right, so it is plus minus 0.6745 times standard deviation is given in the question, and angle is measured with a standard deviation of plus minus 2 seconds. So by calculations, my most probable error is plus minus 1.349 seconds. All right, so So my most probable error is plus minus 1.349 seconds. And students, I would like to reiterate this time that please do not confuse yourself with the most probable error and the most probable value. Most probable value in a given set of the measurements is equal to arithmetic mean of that those set of measurements, and the most probable error is something else, which is plus minus 0.6745 times standard deviation. All right, so in a given set of observations, my most probable value is the arithmetic mean, but my most probable error is 0.6745 times standard deviation. And please do not confuse yourself with the most probable error and the most probable value. These are two different quantities. All right, let's do the next part. We have calculated the first part. Calculate the most probable error. It's plus minus 1.349 times it's plus one, it's 0.6745 times the standard deviation, and we calculated it to be plus minus 1.349 seconds. All right, so the next part is also determine 95% error. 95% error is expressed as E95. All right, and it is equal to plus minus 1.96 times the standard deviation. All right, 95% error is expressed as E95, and it's equal to plus minus 1.96 times the standard deviation. So let's calculate this. This is plus minus 1.96. Our standard deviation is 2 seconds. So our 95% error, or E95, is plus minus 3.92 seconds. All right. Now let's move on to the last part of the question. Calculate the maximum error. All right. As already told that it's impossible to estimate absolutely maximum error, as it would occur at infinity. All right, it's impossible to estimate absolutely maximum error as it occurs at infinity. So in surveying, generally 99.9% error is taken as maximum error, and it corresponds to a range between plus 3.29 sigma to minus 3.29 sigma. All right, and this maximum error is often used to separate gross errors or the mistakes from the random errors. How? If any measurement deviates from the mean by more than plus minus 3.29 times sigma, it is considered as a mistake, and that measurement is rejected. All right, so it's impossible to estimate absolutely maximum errors as it would occur at infinity. So in surveying, generally 99.9% error is taken as maximum error, and it's expressed as E99.9, and it corresponds to a range of plus 3.29 sigma and minus 3.29 sigma, and it's often used to separate gross errors or the mistakes from the random errors. How? If any measurement deviates from the mean by more than plus minus 3.29 times standard deviation, that measurement is taken as considered as a mistake, and that is rejected. All right, so let's calculate this. I have to calculate my maximum error. It is known as 99.7% error, 99.9% error, sorry, and is expressed as E99.9, and is equal to how much? Plus minus 3.29 times standard deviation. That is, it's plus minus 3.29. How much is my standard deviation? It is 2 seconds. So by calculations, it is equal to plus minus 6.58 seconds. All right, so we have completed all the three parts of the question. We have calculated most probable error, 95% error, and 99.9% error, which is also known as maximum error. All right, moving on, let's do the next question. Question number 4. A distance is measured a large number of times a distance is measured large number of times and its 90% error is plus minus 0.8225 centimeters. What is the standard deviation? What is the standard deviation and what is the percentage error for plus minus 1.50 centimeters? All right. So the question is, a distance is measured a large number of times and its 90% error is plus minus 0.8225 centimeters. What is the standard deviation and what is the percentage error for plus minus 1.50 centimeters? All right. 90% error is expressed as E90. All right. And it's equal to plus minus 1.645 times standard deviation. All right, 90% error is expressed as E90 and it's equal to plus minus 1.645 times the standard deviation. All right, and what is the question saying? We have to calculate the standard deviation. A distance is measured a large number of times and its 90% error is equal to this. And what is the standard deviation? I know by expression my E90 or 90% error is given by plus minus 1.645 times the standard deviation. But in question it's given that 90% error is equal to, that means 1 plus minus 1.645 sigma is equal to plus minus 0.8225 centimeters. Already given in the question. So standard deviation by calculations is equal to plus minus 0.50 centimeters. Alright, so I have calculated my standard deviation from the 90% error, which is equal to plus minus 1.645 times the standard deviation. So my standard deviation is 0.50 centimeters, because in question it was given that 90% error was equal to plus minus 0.8225 centimeters. So I got my answer. My standard deviation is plus minus 0.50 centimeters. Now the second part of the question says, what is the percentage error for plus minus 1.50 centimeters? All right. So my sigma is this. My thrice sigma is how much? Plus minus 1.50 centimeters, isn't it? If my standard deviation is plus minus 0.50 sigma centimeters, sorry, my thrice standard deviation, 3 times standard deviation is how much? Plus minus 1.50 centimeters. But we know that 99.7% error, which is expressed as E99.7, is how much? Plus minus 3 times sigma, isn't it? That means the percentage error for this is how much? 99.7%. All right. So it was very tricky part of the question. Our standard deviation came equivalent to 0.50 centimeters plus minus. If I multiply this by 3, my 3 sigma is how much? Plus minus 1.50 centimeters. But I know that my 99.7% error, or E99.7, is how much? Plus minus thrice sigma. And thrice sigma is equal to this much. So the percentage error for this value is 99.7%. All right. Let's move to the next question. All right, this is question number 5. As already told, we are trying to solve as many questions as possible. This is question number 5. All right, and the question number 5 says an angle is measured with a standard deviation of plus minus 10 seconds. Calculate the 90% error and 95% error. All right, so the question says an angle is measured with a standard deviation of plus minus 10 seconds. Calculate the 90% error and the 95% error. 90% error is expressed as E90 and is equal to how much? Plus minus 1.645 times standard deviation. All right, so plus minus 1.64 times standard deviation is already given in the question, that an angle is measured with a standard deviation of plus minus 10 seconds. So my E90 is equal to 16.45 seconds. All right, moving on to the next part. 95% error is expressed as E95 and it's equal to how much? Plus minus 1.96 times standard deviation. So it's plus minus 1.96 multiplied by standard deviation. So it's plus minus 19.6 seconds. All right, so I calculated both the 90% error and the 95% error as well. My 90% error is equal to plus minus 1.645 times the standard deviation, and my 95% error is equal to plus minus 1.96 times the standard deviation. All right, moving on, let's do the next one. Let's do the next question, and the next question is, this is our question number 6. A distance is measured. A distance is measured a number of times, and a distance is measured a number of times, and its 95% error is found to be 1.96 centimeters. What is the standard deviation? What is the standard deviation? All right, so let's try to solve this. A distance is measured a number of times and its 95% error is found to be plus minus 1.96 centimeters. We have to calculate the standard deviation. All right, we know that 95% error, also expressed as E95, is equal to how much? E95 is equal to plus minus 1.96 times the sigma. But in question it is already calculated that 1.96 centimeter is E95. Then my standard deviation is how much? All right, so in question it was given that E95 is equal to plus minus 1.96 times 1.96 centimeters, and I had to calculate my standard deviation, and I know that my 95% error, also known as E95, is equal to plus minus 1.96 times sigma, and I replaced the values, substituted the values, and I found my sigma to be plus minus 1 centimeters. All right, let's do the next question. This is the question number 7. And the question number 7 says, if there is an error of 0.5 meters in a distance of 1000 meters, what is the relative accuracy? What is the relative accuracy? All right. So the question is, if there is an error of 0.5 meters in a distance of 1000 meters, what is the relative accuracy? I know that relative accuracy, or the degree of accuracy, indicates the accuracy attained in the measurements. And in case of linear measurements, it is usually expressed as a ratio of the error and the measured quantity. So my relative accuracy, also known as degree of accuracy, is how much? It's a ratio in linear measurements. It's a ratio between the error and the measured quantity or measured distance for that matter. So relative accuracy is, what is my error and what is my measured distance? By calculations, as I always express my numerator by unity, it is equal to 1 by 2000. All right. So my relative accuracy is 1 by 2000, which means that there is an error of 1 unit in every 2000 measured units. All right. Moving on, let's do the next question. This is question number 8. All right. So question number 8 says, if the standard deviation is plus minus 1 seconds, E 99.9 is equal to. All right, so the question is, if the standard deviation is plus minus 1 seconds, E 99.9 is equal to. We know that E 99.9, also known as 99.9% error, or also known as maximum error, is equal to how much? Plus minus 3.29 times standard deviation. So it will be equivalent to, standard deviation is 1 seconds. So the E99.9 will be equal to plus minus 3.29 seconds, or approximately, I may write it down, it's plus minus 3.3 seconds. All right, my maximum error, or E99.9 or 99.9% error, is equal to how much? Plus minus 3.29 times standard deviation. And already told that it is, in surveying, generally 99.9% error is taken as a maximum error, as it's impossible to estimate the absolutely maximum error because it will occur at infinity. And this maximum error is used to separate mistakes or gross errors from the random errors. If any measurement deviates from the mean by more than plus minus 3.29 times sigma, that measurement is considered as a mistake and that is rejected. All right, moving on. Let's do the next question. All right, let's do the next question. This is our question number 9. If the residuals in 4 measurements of a length are plus 0.01 meter, plus 0.02 meter, minus 0.01 meters, and minus 0.02 meters. The standard deviation is equal to alright. So the question is, if the residuals in 4 measurements of a length are plus 0.01 meter, plus 0.02 meter, minus 0.01 meters and minus 0.02 meter, the standard deviation is equal to. I know that my standard deviation is equal to square root of summation of v square divided by n minus 1. Alright. And these are the residuals. And residuals or residual error or also known as, the third term is variation, and it is equal to how much? Measured quantity minus most probable value. Most probable value. And as I already told you, that the most probable value in a given set of measurements is equal to its arithmetic mean. And please do not confuse yourself with the most probable error, that is plus minus 0.6745 times the standard deviation. And the most probable value in a given set of measurements is its arithmetic mean. Alright, so my residual, also known as the residual error or variation, is equal to measured quantity minus most probable value. Now in the question, my residuals or the residual errors or the variations are given. Now let me find summation of v square first. I'll square them and I'll subsequently sum them. So it is 0.01 alright. By calculations, my summation of v square is equal to 0.001. Alright, so my standard deviation is equal to how much? Square root of summation of v square, that is 0.001 divided by n minus 1. How many set of measurements? 4. So n is 4, n minus 1 is 3. So standard deviation is equal to plus minus 0.018 meters. Alright. Standard deviation is equal to how much? Plus minus 0.018 meters. Moving on, let's do the last question, question number 10. Last for this video lecture. Otherwise, we're continuing with our numericals. We're trying to solve as many as possible. All right. So let's do the last question for this video lecture. This is question number 10. All right. And the question is, if the probable error in single observation is plus minus 0.04 meters and that of the mean is plus minus 0.01 meters, then the number of observations are. All right. So the question is, if the probable error in single observation is plus minus 0.04 meters and that of the mean is plus minus 0.01 meters, then the number of observations are. All right, we know that probable error in a single observation and the probable error in that of the mean is given by this relation, arithmetic mean of that particular observation, and the probable error in that is equal to probable error in the single observation divided by square root of the number of times observations are made. All right, so what is my probable error in mean? What is my probable error in the single observation? By calculations, my square root of n is equal to how much? 0.04 divided by 0.01, that is 4. So if then n is how much? 16. So there are 16 observations. All right, so this was about the probable errors, probable error of the mean and the probable error of the single observation. All right, we know that our most probable error in the single observation is how much? Plus minus 0.6745 times standard deviation. Let me write it over here. Let me rub it first. Most probable error of a single observation is how much? Plus minus 0.6745 times standard deviation. But the most probable error of the mean is given by how much? Plus minus 0.6745 times all right, so the expression I use the same one and I calculated my number of observations, which came equivalent to how much? 16. All right, so with this we conclude today's video lecture. Thank you for watching.